Thank you all for joining us this morning. We are so happy you are here. I'd like to welcome you to today's webinar session with eRefCom and Tubacaat-Key. I have a couple of slides that I need to go over before we get started. First, our antitrust disclaimer. We won't be talking specifically about money or projects or contracts. We ask that you keep your mic muted during the presentation. You're welcome to ask questions during the Q&A portion. Please, when you do speak, please speak clearly so we can all hear you. And also silence your phones. There is a raise your hand feature in the Zoom meeting. That's one of the ways you can let us know that you have something to add. We will be using Slido today for our Q&A. You can access Slido either by slido.com or with this QR code. The event code is RefCom. And I'm going to turn the screen over now to Sanjay Lodha with Tubacaat-Key.
Thank you. Good morning, Becky, and good morning, Maria from RefCon. Thank you, audience, for coming to my presentation. Today, I'll be speaking on Tubacaat technology. That's anti-cooking solutions for the fire heaters. And here is the agenda that I'm going to take you through. I'm going to take you briefly through the parent company Tubacaat. Then I'm going to explain you the Tubacaat concept, how the technology works, some of the product characterization. There are many properties of this technology that one must understand to see how this technology works. Then I'm going to take you through coke deposition in fire heater tubes, whether it's a vacuum distillation unit or a Visbreaker or a delayed coker. Then I'm going to present you a chemical inertness study and a coking resistance study that we did with the European University. And we'll have some very interesting results on the coke formation, coke deposition, and side reactions that make the coke. And then I will take you through some applications and case studies, which some of them already been implemented, some are in the pipeline, and some are yet to be implemented. And on top of that, then I'm going to give you one more case study on the commercial application we have for the anti-corrosion and on a conclusion. So I think I'll take maybe 30 to 40 minutes. And at the end of that, as Becky said, we're going to have a Q&A. So can we have the next slide, please? So just briefly on the Tubacaat, it's a global leading supplier of seamless stainless steel and high nickel alloy tubes, has a presence around the world, 15 manufacturing sites, including Spain, which is a headquarter in Bilbao, USA, Austria, Italy, India, Thailand, Norway, United Arab Emirates, and Saudi Arabia. And we do close to $1 billion in sales, and we do the entire cycle chain from making our own steel at our mills in Spain, and extrusion, cold and hot finishing, and finished products, whether they are flanges or tubes, all the pipes, and then master distribution in more than 30 countries, and a commercial network. Next slide, please. So now let me tell you a little bit about the Tubacaat and the key advantages. So this Tubacaat technology is a proprietary, in-house developed and patented technology. We probably spent more than 10 years in developing this technology. And since we're the manufacturer of seamless stainless steel tubes, we brought this technology as a value-added service for our customers. And this technology is automated in-house technology, has a complex multiple steps to make this coating happen. So the first step is called the surface preparation. Whatever the substrate, it might be a new tube or the old tube that goes into a heater furnace. It goes through a surface preparations, which includes the sandblasting and the chemical treatment, because the surface has to be very, very clean with the proper roughness. to prepare the coating. The second stage is auto-controlled coating process that is applied then on the surface through automated process. And once that is done, then it is goes through an industrial scale furnace where we vitrify it to bring the chemical bonding between the substrate and the tube. And with this multiple complex procedure, then we get the Tubacaat technology, and it brings out the properties that combines the silica ceramic based material along with multiple inorganic metal oxides such as zirconium, zinc, sodium, magnesium, and other compounds, fused enamel to give you the outstanding corrosion resistance in different medias and thermal conditions, temperatures up to 1500 degrees Fahrenheit, hydrochloric acid, sodium hydroxide, sulfuric acid, many corrosive conditions. Also, it has a very high abrasion resistance. The hardness of coating is 4 times. So it's a very good for abrasion and erosion applications. Also, because it's smooth and inert, it has a very good anti-fouling properties. So together, these properties combined were able to provide a long-term, reliable, and competitive solution for the critical process equipments in the refinery and petrochemical plants. Next slide, please. And so the critical applications we focus on, of course, oil and gas, chemical industry, petrochemicals, power gen, but the equipment we work on are critically are the furnaces, heat exchangers, boilers, tubular reactors, and condensers. This is where we employ this tubular technology, and this coating can be internal coating or can be external, depending on the application, depending on the conditions, and also these coatings can be customized. Working with our R&D and Technology Center in Spain, they can be customized for different applications.
I would propose to the team that we.
Next slide, please. Can you mute somebody who's on the background, please? So I'm going to take you through some key properties on this Tubacaat technology, such as the morphological properties, mechanical properties, chemical properties, and the thermal properties. So the audience here will have a feel for why these properties and how do they help in the good things it does against the corrosion, against the fouling, and against the coking. Next slide, please. So this coating is a continuous homogeneous layer managed through an automated process, as I said, and through a rheological suspension properties. In automatic control process, this coating is 150 micron, 0.15 millimeter, and we're able to control the thickness across the length of the pipe with the same thickness, where we measure minimum each and every at the start, at the middle, and at the end, and we get minimum, maximum, and average thickness properties, and we're able to control the thickness in a very unique way. Next slide, please. So this particular slide is a very interesting, shows the roughness of these coated tubes. What you see on the screen is on my left, a substrate that's not coated. On my right, the same substrate that's coated. And if you look at the average thickness and the RZ, which is the highest point and the lowest point difference, you would see a drop of about 97% from the uncoated tube to a coated tube. Initially, we bring you the surface of the coated tube that's equivalent to a glass finish, a mirror finish, very smooth. And we know the smoother the surface, there is a less resistance to the flow, there is a less resistance for the particulates and metals compounds to deposit on the surface and begin the fouling process. So by having this rough surface, we're minimizing any tendency for the particulates or any other matter to deposit and begin the fouling and the corrosion process. Next slide, please. How about the abrasion test? So what we have on the screen on my left is uncoated tube, and at the bottom is the coated tube. And we do a abrasion resistance test, a standard ASTM test with the abrasometer. And after 10,000 cycles, when I compare the uncoated tube with the coated tube, we see about 94% decrease in the mass loss compared to uncoated tube. And that's quite significant. And that's coming from, again, the hardness of the coated tubes. And that's a very important property to have for the critical process equipment. Next slide, please. This slide is another interesting slide that shows on the left side the load displacement curve. When you put a certain amount of load, how is the surface reacting? And when I look at the hardness of the coated tube, that is 840 Vickers number compared to 220 for the base material. So I'm able to bring a hardness 4 times higher than the base material. But it does come at a cost to pay. And that cost is on my right side. If you look at the elongation, once you coat the tube, you can elongate up to 1.5%. And beyond that point, if you were to do physical bending or physical elongation, then there will be a damage to the coating. So there is a price to pay. If you have a U-tube or a bend tube, first thing is to bend the tube first, and then we do the coating. So that can be done, but it cannot be done the other way. And that's an important point to remember. Next slide, please. In any refinery or petrochemical process, you have startups and you have shutdowns. You have rapid heating and rapid cooling. Just like your online spalling in a diluted coker, or if you have a steam air decoking, or if you have a pigging, but at least the first two, where you have a thermal shock, expansions and contractions, that's where this property comes in very handy. So what you see on the slide is we take the thermal cycling up to 450 degrees Celsius, close to, I would say 850, 900 degrees. And then we do a rapid cooling, and we do many, many cycles over. On my right side, you see another chart where we take the temperature from 1200 degrees Fahrenheit to 1500 degrees Fahrenheit in intervals, and then we do a rapid cooling to make sure that there is no damage to the coating or there is no delamination, because that's exactly what happens in online spalling. You have a contraction and expansion along with the steam heating and steam cooling, and the coating material expands and contracts accordingly, similar to substrate. So this property is very important. Next slide, please. Okay, as we all know, another important property is any heat exchanger, any heat transfer media, the fouling is a very, very important factor, very important discussion. Across the refinery or petrochemical plants, we have hundreds and thousands of heat exchangers, and they all have fouling issues that happens due to the chemical reactions between the products or the precipitation, corrosion. And so critical part is how do you minimize that fouling part. When you apply this coated tube inside the tube, what you see here is a deposition rate of the particulate matter or the fouling matter will decrease because the tubes are chemically inert and they are very smooth like a glass finish. Also, the removal rate of this fouling material will increase because it will not stick to the surface of the tube. And because of that, heat transfer loss, which you would have otherwise, will reduce significantly. And since you don't have that fouling and the heat transfer loss, your fluid flow, the process throughput, will maintain at a steady state. And that's an important characteristic of the Tubacaat. Next slide, please. This is a study done on the fouling rate or rate of fouling by a major US refinery over a period of 7 months using crude oil, heavier feedstock. And what you see on the screen here is rate of fouling at a given velocity. The blue dots are for the baseline carbon steel tube, and the red dot, which was taken at a given velocity of 1.2 meter per second, you can see there is a significantly higher fouling avoidance of coated sample, and eventual deposition is not adhere to the surface because it's very easy to remove. And you can see a difference as much as on the high side, 4 times the difference in the rate of fouling being reduced for the coated tubes. Next slide. This is just another example on the chemical properties. I just took one example of hydrochloric acid and sulfuric acid, and over 2000 hours, 10% hydrochloric acid at 22 degrees and sulfuric acid 30%, which is very corrosive. Using the European test in both conditions, again, this Tubacaat material holds very well. There are many, many more tests we've done with the molten salt, sodium hydroxide, you name it, and this holds very well in most applications. Next slide, please. So in summary, this coating is vitrified above 1470 degrees Fahrenheit, about 800 degrees Celsius, and because of that vitrification, there is a chemical bonding and glass-like properties between the bonding between the substrate and the coating material and the glass-like properties, and because of that, we're able to bring that coating in such a way that it has a very low roughness, and that helps you with the fouling and coking resistance. A chemical bonding that's created due to vitrification, and very strong chemical bond that gives an excellent corrosion resistance. The hardness is 4 times, that gives you a very good abrasion resistance and erosion resistance. And then I already said the chemical bonding gives us a window where you can operate these coatings close to 1500 degrees Fahrenheit or 1550 degrees Fahrenheit. And that's another one that works very well. And of course, as I explained, this coating is an automated proprietary multi-step process. So it can be applied only in our factory and not at site. What we do at the site is small repair jobs, small welding jobs with the portable instruments. Otherwise, most of the work is done in our factory. Next slide, please. Now I'm going to explain you the coke deposition in fire heater tubes. Next slide. So I think most of your audience, you work in a refinery, whether you work in a Visbreaker or a diluted coker or a crude unit or a vacuum unit. I think we know we have this high conversion process units that process low value, heavy feedstocks, whether it's a gas oil or vacuum residue or atmospheric bottoms. And you try to go through a conversion unit to make high value distillates or clean fuels. I'm showing a picture here of a diluted coker. So besides the distillates, you also make coke. And in the process, you're cracking, thermally cracking the feedstock, and you're creating a coke that deposits in the radiant section of the furnace, and that is a problem. Next slide, please. So as you can see and look through the tube, as the coke layer grows, what happens is, of course, your heat transfer reduces, you have tube skin temperature that goes up, you have hot spots, your effective heat transfer area is reduced, you have a pressure drop, and you come to the point of end of run, either due to high temperatures or due to a pressure drop. And what you have to do is shut down or do online spalling, or you have to do steam air decoking, or you have to do mechanical pigging. Next slide, please. And when you do that, of course, there is a cost reduction in throughput, huge conversion cost, maintenance cost, safety cost, and all that is a dollar value. So now let me take you through a chemical inertness and coking resistance study that we did with the university in Europe to just explain you again some more properties on how this technology of Tubacaat works against the coking. Next slide, please. So the coking tubes have two things that works very well for the heater tubes. One is these coatings are chemically inert, so they minimize the coke forming reaction. Second part is once you form the coke, does it stay in the coker furnace tubes or does it move further to the coker drums? And it has this anti-fouling, very smooth surface, anti-hearing surface that allows minimum coke deposition. And because of these two properties, you get significantly longer run length between the spallings or coking. Since the surface is much cleaner, your fuel consumption is lower. And since you don't have that many spallings and piggings, there is improved safety and reliability part. So the advantages are very well explained. Next slide, please. So this experiment was done with the European University, where we took the chemical compound dimethyl ether and we cracked, and if we crack it properly, it's equimolar cracking into carbon monoxide, hydrogen, and methane, and it won't generate any coke. That's a thermal route. But it doesn't happen in the real life. You have many side reactions, Boudrod reaction that breaks down the carbon monoxide to CO2 and carbon, methane decomposition, again hydrogen and carbon, and this carbon is what you don't want in the furnace tubes. Next slide, please. So what we show in this particular slide is, and then this experiment done at the university in a furnace heater, we have multiple cycles. What you see here is one heater without the coating, other one with the coating. Cycle 1, if you look at T10 conversion, for the non-coated tube, the temperature is 587 degrees. And then when you shut down that and start again, T10 starts 100 degrees earlier, which indicates you're promoting the carbon forming reaction because the metal surface takes an active part in promoting the carbon forming reaction. But when you do that with the same substrate but the coated tube, on the cycle 1 and cycle 2, what you see here is no difference in startup run T10 temperature, T50 and T90, almost identical, which proves that the coated tubes, which are chemically inert, they prevent formation of or minimization of coke forming reaction when you go through the multiple cycles where the active metal does take a part in promoting carbon formation. Next slide. So this slide shows carbon forming reaction, and basically we just do the equation through which we know what is a carbon formed. And again, what you see here is without coating and with coating, there's a huge difference in the amount of carbon that you make, a factor of 10 times lower carbon formation. Next slide, please. Then once you make the carbon, again, where does the carbon stay? Does it deposit on the tube surface or no? So what we do is in this experiment, we burn the carbon through oxidation process and we integrate CO2 chromatograph curves. Again, on the surface without coating, you can see the very high CO2 curves and a significant period of time over 400 minutes, 360 minutes. But when you see it with the coating, there is no CO2 curves and it goes away within 60 minutes, reconfirming the carbon deposition is very, very low on the coated surface. Next slide. So in summary, the chemical inertness of coated surface avoids coking reactions. Carbon formed is 10 times lower, and whatever the carbon that's formed, carbon deposition of that carbon is 100 times lower. So significant improvement both in carbon formation and carbon depositions with these coated tubes. Next slide. So now I think I'm going to get to the real subject of the case studies. And as I said, some of them been already implemented. Some are already in the pipeline and some are yet to be implemented. So I put together 5 or 6 case studies and different examples. And now I'm going to go through it. Next slide, please. So this one is a European refinery of Visbreaker, 15,000 barrels per day. And you can see the picture of the Visbreaker with the furnace and upstream heat exchanger. And so they have a quite frequent shutdown for pigging. To be accurate, they do 2 piggings per year. And that is about 8 days of shutdown. That's a significant loss of production. Then they have a pre-heat exchanger upstream of the furnace that is also taken out of the service due to coke accumulation, and a poor heat transfer that gives you a higher fuel consumption. So they agreed to go with the Tubacaat solutions, 4-inch dia, inner coating, schedule 80, 317 stainless steel, and also the flanges and the bends. We supplied that. Next slide, please. So trial after 9 months, now it's been 14 months, but this was done at the 9 months. What we saw after 9 months is a very thin coke layer, not even detected by the radiographic test, and in essence, 75% reduction in the coke deposition. And whatever the coke that was there was very, very easy to remove, 3 times lower the water pressure. You can just put some water and it will come off. And basically confirming that in commercial applications, these coated tubes are able to help in minimizing the pigging or similar activities. And what we saw in the conclusion, 8 days of downtime or 7 days of downtime, throughput value was $1.1 million for this given unit, and some other benefits such as a reduction in the maintenance, a benefit of fuel consumption and heat exchanger cleaning, altogether $1.5 million per year. Return on investment much less than 1 year. Next slide. This one is delayed coker unit in Asia. It's a 1 delayed coker with a capacity quite big. I think it's the second largest in this part of the world. 124,000 barrels a day. Has 3 furnaces, 6 passes. Each pass has 30 radiant tubes. Very common P9 material that's used in mostly many delayed cokers we see around the world. Next slide. So they have a frequent decoking as required due to coke buildup. One, because of the high pressure drop. Second is the high tube metal skin temperature. And they take out each furnace out for pigging every 3 months, and also online spalling every 30 to 45 days. And they do 2 passes per furnace, and they have 6 passes per furnace. And during the pigging, their capacity is reduced to 70%, and during online spalling, their capacity is reduced to 93% while they do the spalling. And with our modeling work, we work with the customer based on their information. Every time it's taken out for service for pigging, the cost is over 4 days, 3.6 million every 3 months. And also when they do the online spalling, reduction in throughput, about $125,000 per cost per furnace. So it's quite significant. Next slide, please. So we did Tubacaat technology solution modeling for the unit, and what we see here is the cost of the tube over a 5-year period. And when we say the cost, we include the cost of the tube along with the coating advanced coating Tubacaat, plus cost due to reduced throughput during decoking and cost due to higher fuel consumption. And by extending the run length without decoking by 3 times, we're able to give them $10 million benefit per year. Over 5 years is about $50 million if they were to do all the tubes and radiant section with the Tubacaat technology. Just the online spalling, instead of 30 to 45 days, it would be 90 to 100 days, and mechanical pigging, instead of every 3 months, it will be 8 to 9 months. And that's a significant value for any refinery, any customer. Next slide, please. Now, everybody has questions, and I saw some questions in the chat room that does this coating work with the online spalling or steamer decoking or mechanical pigging? So I just put a slide, and that should answer many questions. So coating is designed to withstand online spalling because it's designed for high temperature, is designed for the thermal shock, and the coating has the same coefficient of expansion, thermal expansion as it is for substrate. And as a substrate can change from P9 to 347H or anything else, we're able to customize the thermal coefficient of expansion for each substrate. Second part is mechanical pigging. Of course, our regular pigs, which are 82 or 84 Rockwell C, they are a bit too hard for something like this coating. So we have worked with the coking company, and we have come up with the pig studs. Those are a little bit softer, 64 Rockwell C or 800 Vickers number, and they can do the mechanical pigging without any damage to the coating surface. And they can be available to any customer anywhere in the world. So we just modified that. And also remember, when we use these coating tubes, we're reducing significant amount of inorganic contaminants, such as the iron sulfide and the solid coke. So the mechanical pigging requirement is significantly lower, but also the material you have in the tube that's coking is significantly lower for the inorganic materials. That's another part. Next slide. This one is another coker in Asia. Again, a P9 9 chrome material, 42,000 barrels per day unit, and they do spalling every 50 days, 7 spalls per year, and every time they spal 6 days per spal. That's 42 days they run at 85% throughput. If they were to run Tubacaat technology, their 85% throughput will reduce from 36 days down to 12 days. They would have 24 days of savings at a full throughput value. And that's $3 million per year benefit just from the throughput. This project is in the pipeline, in the budgeting phase, and it will be implemented sometime 4Q 2021 or sometime in 2022 period with this particular customer. Next slide, please. This one is North American Refinery and West Coast America, and their heater tube material is 347H, which has a higher end of run temperature, maybe another 50 to 100 degrees Fahrenheit over the P9 material. So many companies now prefer to go for 347H, more expensive, but then it gives you higher end of run temperature, and that helps you on the OpEx side. So this heater requires, again, online spalling every 2-3 months and mechanical pigging once per year. And it's a total of shutdown is for 6 days for pigging, and throughput is reduced to 75% for spalling for 16 days. And again, potential savings of $2.5 million. The project was to be implemented in March of 2020, and because of the COVID-19 and oil scenario, now this project is now been moved to 2021. We'll keep you posted on the outcome of this trial as well. Next slide, please. This one is something we just did recently, vacuum distillation unit furnace. This furnace outlet line had a severe coking problem. Again, it's a North American refinery where they have this outer line replacement due to coking. These are 8, 10 inch and 12 inches OD tubes, and they have to replace them every year or every 13 to 14 months. Frequent decoking operation and mechanical pigging. A lot of traces of polythionic acid stress corrosion cracking. And we just supplied these tubes. They would be installed very soon. Base material is 317 L stainless steel. OD is 8 inches. And I think working with the customer, validating the modeling work and feedback, we expect return on investment in less than 1.5 years. Again, I will keep you updated in our next presentation on the future performance of this unit. Next slide. This one is rigid hydrocracker, again in North America. They have 8 rigid hydrocrackers feeding very heavy feed, gas oil feed, and they have close to 800 risers. Those are used for the proper feed distribution in the reactor. Temperature close to 750 degrees Fahrenheit, 130 bar pressure, and due to the velocity regimes of the hydrocarbons, they have a severe fouling at the bottom section of hydrocracker risers. And once they have this fouling and the cracking, that leads to the maldistribution, and they're not getting the conversion they would desire. So with the coating, they will be able to minimize this erosion and the fouling, and expected to give a far better conversion. Again, this project is for 2021 due to COVID-19, and we'll keep you posted on the benefits that will come out of this trial as well. Next slide. Another vacuum unit furnace in Europe has been running close to 2 years now without having to decoke. We don't have any data other than it has not been out of the service. It has not been gone into decoking. Again, 317 stainless steel, OD is 5 inches, schedule 40, and you can see the tube surface. Trial is in progress now. It's close to 2 years. Next slide, please. So I'm going to take you through one more example of commercial example. I think I covered quite a bit of coking issues in the delayed cokers, Visbreakers, and vacuum units. Now I'm going to take you through another corrosion issue, again with the refinery in North America, where they have a huge corrosion problem and how they implemented the Tubacaat solution. Next slide, please. Okay, as you can see on the screens, the flue gases in this recuperator heater in the coker calciner, extremely corrosive. I mean, you got sulfur, you got bandits, and you have a very corrosive environment. Metal surface of 570 degrees Celsius, close to 1000 degrees Fahrenheit. You can see the tubes basically can't survive this environment, and that causes chemical corrosion due to these bandits and sulfur. They have to plug the tubes, and that's a huge efficiency loss and operation cost, and then they have to reduce the throughput in a coker calciner. Their current material is TP310. They tried many other metals and alloys, nothing worked. And we happened to meet them in one of these conferences similar to what we're doing today with the RevCon. And they said, well, we tried everything, nothing really worked. So let's try the Tubacaat technology. And let me show you what happened in the next slide. Next slide, please. So what you see here is we supplied some 9 TP310 tubes, outer coated in this recuperator heater. And they were installed in May 2015, now almost 5 years ago. And after 10 months, when you see through a furnace window, what you see here is uncoated tubes are completely broken and blinded. You don't see them melted, whereas the Tubacaat tubes, all 9 of them are fully visible, even after suffering the overheating at temperature close to 1500 degrees Fahrenheit. So the light did so much that they decided to go for a full commercial trial, full commercial run, which I will show you in the next slide. So they went with 800 tubes, TP310, and as you can see, the 2 different color schemes of the Tubacaat technology. It's not just because we like different colors. They were designed for different temperatures. As I said, we designed these tubes and customized these tubes coatings for different applications, different conditions, different temperatures. So some of the tubes you see were designed for 700 to 750 degrees Celsius and some for another 20 degrees higher temperature. And they were installed in April 2017. Next slide. So what you see here is, again, when you look through a furnace window, middle picture, what you see is a unique, consistent temperature profile across all the tubes. You don't see any tubes broken, melted, or plugged. Full heat transfer, full throughput capacity they're utilizing, and they got close to 2 years, 3 times the cycle length they would have otherwise. Savings of close to $2 million for this customer, which is a West Coast big refiner in the US. And again, they were very happy with this particular outcome. And we continue to work with them now as a regular supplier and multiple other applications. Next slide, please. So let me take you through a conclusion slide. Next slide on the conclusion, please. So in summary, I think I've taken you through the properties of Tubacaat, then case studies for the various units, including the corrosion. And in summary, what we see, whether it's a DCU, vacuum unit, VDU, or rigid hydrocrackers, or any corrosion problems you have in any other unit, Tubacaat is able to give you a longer run length, improving overall throughput, and that makes it very significant. Easier and much less frequent cleaning, reducing the maintenance, helping with the safety part, and that gives you a tremendous value. Cleaning, of course, since the surface is cleaner, heat transfer is much more efficient. You have significantly reduced fuel consumption and reduced carbon footprint on the environment. Reliable, as I said, we developed this technology over a 10-year period. We're in the pipeline to do many commercial applications and trials for different applications. We have an in-house R&D, metallurgy, huge department, and technology department where we work with the customer problems, customers' data, and we work on the cooperation, collaboration front. We're also working with a number of licensors where they exclusively will use our technology for their heater technology in a given delayed coker unit. And this coating can be applied to many metals, metallurgy applications, whether it's a carbon steel, stainless steel, or nickel alloy materials. And so in a sense, we call it disruptive innovation technology when you compare with the conventional technology where you not only upgrade the metallurgy, you do the cladding, you do many more things, and it still doesn't work. And that's why we call it new frontier technology, reliable so far what we've seen with what experience we have. Next slide, please. What I show you here is our brand new plant of the Tubacaat technology, which we set up in Cantabria, Spain. It's in northern Spain near Bilbao, and that's where we make and apply these advanced coating tubes. We can work with the existing tubes, old tubes or the new tubes. We can source these tubes for you, or you can supply us the tubes. My email and number is on the screen for you to reach me. I think this is my last slide. I'm going to conclude this presentation with this last slide, and then I'm going to open the floors for the next 20 minutes for the Q&A. So thank you, Becky, back to you. If I can get the Slido. Okay, good. So we see a lot of people are interested in the run length. Which is great. Okay, so the first question was, I'm going to take this. How well does this coating withstand pigging? This question came and I think I answered in my slide. This coating can withstand not only the online spalling, steam air decoking, it can also withstand the mechanical pigging. First of all, the pigging frequency will be significantly reduced because this technology minimizes the formation and deposition of coke, and in particular the inorganic coke, which is a very solid coke and iron sulfide. And of course, as I explained, this coating can withstand the mechanical pigging with the pig stirds of 62 Rockwell C, 800 Vickers number, where we offer the technical assistance and collaboration. Then there was a question, what shall be the coating reapplication frequency? Of course, very good question. I like that question. So first of all, whatever your tube metallurgy is, whether it's a P9 or 347H, your tube metallurgy life would remain the same. It would not change. You would have an incremental life because your tubes are not exposed to the process conditions. And now, as far as the coating is concerned, we give minimum value of 5 years for the coating to work in the given, and of course, it depends on your operating conditions and how you operate. It could be much longer, but 5 years is very reasonable for this application. At the end of 5 years, of course, you can recoat the same tubes, or you can have a spare batch, because return on investment is very, very attractive. It's less than a year. It does have a lead time. If you to source the tubes for you, then lead time is 3 to 5 months. If you already have the tubes in stock, then we can do the lead time significantly lower. There was a question from Pradeep Shau. He said, is there any efficiency loss due to coating adding to fuel consumption? A very good question. So all of the things we've done so far that show that when the coating is applied, the heat transfer is much more effective. There is a less coke in the tube, 75% less coke. Heat transfer is more effective. And what we end up showing is savings in the fuel consumption. It varies again from plant to plant, but somewhere between 1 to 2% savings on the fuel consumption, and throughput that's sustained. There is a question from Bartolo Rodriguez. Do you propose to use the coating in all tubes long, or not only in the radiant tube section? Are you coating into return bends? So I think I'll answer this way. We coat radiant tube sections. We also coat the recycled bends. We also coat the Mueller plugs if it's required. We can coat all of that. But since the coking happens more in the radiant sections, that's where you have the higher temperatures. That's where you have the maximum coking. It makes sense to use this technology preferably only in the radiant section, because that's where you have a significant problem as compared to the convection section. And again, feel free to write me. We can go, I think one customer now we're working with, they have a tube length of 26 meters. So what we do in that case is we can coat maximum length of 12 meters. So for 26 meters, we have 3 pieces. That's how we coat, and then they're welded into one piece at the customer site. Let me see what other question we have. how can we estimate the cost of applying this to an existing coker? Well, I think I love this question. It's coming from Sim Romero. Thank you, Sim. I really love this question because this is how we work with every customer out there, because it has to make a sense for him for this to work. And so the way we work with the existing coker is, I think I had a case study which I showed you. Most of these cokers are existing cokers. So there are two ways to work. One, we will get your field operating conditions from you. We will find out how often you do spalling or decoking. Then we'll put the modeling work and technology work together with the value proposition, in which case you may have to buy a spare batch of tubes because your shutdown is for a very short period of time, 3 weeks, 2 weeks, 4 weeks, and you don't have enough time then to coat, send the tubes to us and coat. So what we recommend to many customers is we buy a spare batch, or we supply the spare batch of tubes that are coated, and they come to you handy before the shutdown, and then you install them in the shutdown within your opening window. And the tubes you already have there, let's say they're only 2 or 3 years old and they're in good condition, that can be your spare batch. You can ship those tubes to us at our plant, and we can coat and then have it ready for the next cycle. So I think one customer we showed you from Asia Refinery, that's exactly they will do. Have this spare batch ready when they need it, and that would be the way it will work. Let me see. I think, okay, there is a question from Ian McClero. Let me get to it. What is the emissivity value for the external coating? I think we have a slide on that. The emissivity value is somewhere between 0.83 to 0.87. And I have a slide. If you write me email, I will show you. We tried on different metallurgies and different formulas of coating, and that's what the emissivity is for the external coating. And Ian, I'm happy to send you a slide if you write me an email with the details on that. Very happy to do it. Absolutely no problem. I like a question here now from, oh, it's gone. There was a question from Mike. Okay, how are the tube sections joined together? Are the welds coated in the field? Mike, thank you for that question. We get that question from all our existing customers. So let's say if your tubes are up to 12 meters in the length, then of course they come in one piece. But if you have tubes that are longer than 12 meters, let's say 20 meters or 24 meters, let's say it is 24 meters, then we will have two sections of the tubes, 12 meters and 12 meters. And then we supply the two sections to a customer, and they will have these two tubes welded at the site. We give them technical assistance on the welding procedures, and that's how they're welded. Now, the next part is the point at which they're welded, the inner part. That particular part at this time cannot be coated. And that is not a problem because you have a whole length of the pipe that's coated, and this is only a small portion with the orbital welding, less than 0.3 millimeter penetration on the welding. What we have seen in the field, these small areas of welding which are not coated, there is not much of accumulation of carbon based on our field experience. Also based on the independent work done by the consultants and experts, they have reconfirmed that there is not formation any deposition of coke in the unwelded area. And third part is there is a good enough velocity through the tubes, and then you have this inert material and a smooth surface. So coke just keeps moving, and unwelded part that's not coated is not an issue at all in our experience. Somebody asked me, Francisco Fernandez, he asked me, can you share your contact details, please? I think I'm going to have to ask Becky or Marlia from Revcom, or maybe they can show that slide again where my contact details are. And of course, we have an office in Houston, Texas. My colleague, who is Jorge, who is also in the conference, he can be also your contact. He's also there. But If anybody can show the last slide, I think my contact details are there. And also Becky and the RevCom organizers can share my details. Yeah, those are my contacts. I can write down asloda@tubasex.com. My phone number is also there, and we can do that. Please note it down, and you can also approach Repcon, the Coke Busters, one of the top leading companies for decoking services. I think to reach out to. That's another company we work with for the decoking for our customers. I think I have 6 more minutes or 5 more minutes, and I saw some more questions. I think there was a question about, can this coating be applied in situ or ex situ? And I like that question. So as I explained, this Tubacaat technology is a proprietary, advanced, significant process with the multiple steps, surface preparations, automated application of enamel or coating material, and then the furnace vitrification. That is only done at the industrial scale unit. So most of the work is done at our plant in Spain. Only the small field work like the welding, material coating from outside, or repairs can be done with the portable instruments like resistors, where we supply the coating enamel to a customer. We provide the technical support, and we also do the performance monitoring for a given diluted coker unit, whether it's a pressure drops or a temperature profiles or thermocouple temperature measurement over a period of cycle of that cycle. We do that working with the customer. I have a question here from Mike Baumert, Plaintill Resources. We're already working with the Plaintill Resources R&D for a trial, and a question is, how is pigging impacted? What impact? I think how is pigging impacted already answered this question. Our coating is good enough to work with it. And then there was a question, what impact does the ceramic have on IR heater scans? So what you would see is in the scanning, as I showed you in one furnace, you would not have a hot spots. You have a unique temperature consistent profile on your heater temperature scans and TMT readings, and it will be a much longer time from your startup run to end up run, even within a smaller temperature window, because you're not coking as much, you're not fouling as much, you're not depositing as much coke. So the end up run reaches much slower compared to what it would be otherwise without the coating. And that's how the system works. So I think we recommend you have the thermocouples, you measure the pressure drop, you do the heater scans, and when you shut down, you do a videoscopy and you do the other checks to make sure I think we meet your requirements. Let's see now. I think I have 2 more minutes. Let me see what other application. I think I answered coating application. I think there is a question. Grateful to share your slides to us for better understanding. This has come from one of the customers. I think I'll leave it to Repcon team to share the slides. Of course, it may be on their website, but we're open to it. And again, we'll be happy to share it. I think you've seen my contact details. Feel free to approach me and I'll be happy to send you a PDF copy. Let's see. I think this does for the Q&A session. A lot of good questions. Oh, there is a question from John B on what is the minimum ID you can coat. So we did a lot of work on the ID coating for the smaller size. And I think we spent maybe last 2 years because one of the big refiners in the US, they wanted to coat the small ID. So currently we can now successfully coat 25 millimeters ID for the ID range. 25 millimeters is the minimum. And we can again give you all the technical commercial guarantees. Many heat exchangers in the refineries are between 21 to 25 millimeters, and we can happy to do it. And as I can see, I think most people love the higher run length. and then we can see the OPEX, unit throughput, and unit reliability. So run length is what people want, and this technology would give you that run length working together with as your partner. Feel free to contact us. And I think many people answered our second question, that was, what is a decoking method? So 30% of the people use online spalling, and 15% go for mechanical pigging. So I think if you need a help with that, Tubacaat is the technology to explore, to evaluate, to study together, and we can have a solution for you, working with you through this Tubacaat technology. I think with this, I will conclude the Q&A session. We're right at 60 minutes, the time, a very generous time given by the RepCom team, by Marlia and by Becky. I really thank you very much. And I think I will feel free to reach me, and I hand over back to Becky and the team for the closing comments.
Thank you so much, Sanjay, for that great presentation. There were so many wonderful questions that you did not get to, but we will send those questions to Sanjay so that he can reach out to you directly. There are a couple of upcoming webinars that I'd like to draw your attention to. Next week, we have a webinar presented by Aspen Aerogels about better DCU performance through smarter insulation design. And you can see that there are several throughout the month of September and October. Also, we are hosting RefCom Global, our virtual delayed coking conference and exhibition, the first week of November. The information and details are being updated on our website at www.refcomglobal.com. We are starting a promotion where we are offering 2 complimentary conference passes to each refinery site that has a DCU. You can contact me for details if you would like to participate and are restricted by budgetary cuts. With that, I'd like to thank you all for joining us. We hope that you will join at a future eRefCom webinar in the future. I will be sending out a wrap-up email in the next day or so with Sanjay's details, and we will work to get his presentation posted on our website so that you can access it for your reference. Thank you all so much, and have a wonderful week.
And thank you, Becky. Thank you, Marley. Thank you, RepCon, for excellent digital Zoom flawless execution. Couldn't do without you. So sincere thanks to you both. Thank you very much. Thanks to the audience.
Thank you, Sanjay.